Hello, my name is Matthew Gonley and I am a Hume Scholar. I am majoring in data-centric computing within computer science as well as psychology. This semester I've been working on research with differential privacy and machine learning, with this poster being on a kind of a utility privacy trade-off and the Netflix challenge. So for our background, our research was into the anonymity and de-anonymity involved in a data set and the ability of an attacker to de-anonymize and identify individuals within the data set that is thought to be anonymized based upon a few pieces of information they might have on the individual. Because much of anonymization is done by removing identifiers such as people's like names or date of birth from a data set. But that does not prevent people, an attacker, from re-identifying them with quasi-identifiers and other information they might have about an individual that would be found within the data set. So our objective was to see how does perturbation affect the outcome when compared to the ground truth in kind of two separate experiments that were conjoined. One was a de-anonymizing users within the data set. The other was a recommender system. So part of the question was, though, how much information do you need to re-identify an individual within the data set? Specifically for us, the Netflix prize data set, which was a project we were kind of creating and rerunning from one of our references, Narayan's robust de-anonymization of a large sparse data set. And as well as how much error can they be within the data set and still allow an attacker to re-identify a person. The thought process of that would be that a company that is putting out data might slightly shift the values, perturb the values to make an attempt to anonymize the data. And we're kind of testing to see to what extent does that actually do so. So our objective was then, with the data set we have, to score and re-identify users given a portion of their information, which would be a rating of a movie and the timestamp, and to see if they could be re-identified within the over 480,000 distinct users we had over the 17,000 distinct movies. And it was further to see the extent of perturbing the data, the extent that would have on the accuracy of re-identification. So for the de-anonymization of the data, we randomly selected 5,000 users from the data set, 5,000 distinct users, and took 8 sets of values, being their rating and the timestamp, from those users and used that as our auxiliary data. And that's what then we scored every user in the data set on to find the best score. And then if there's enough of a distinction between the top score and the second best score, then we would say that someone was re-identified. And if the re-identified person was the initial person, it was correct. Otherwise, it was a failed re-identification. So our results found for the unperturbed data a 96.41% re-identification rate within the 5,000 users, which was a representative sample of the whole data set. And then the rate went down to 93 for 6 value sets of ratings. And we even went down as far as 1 value set, and we had a less than 1% success rate. And we also did it with perturbed data with a perturbation rate of 25, 50, and 75% respectively. At 75%, there was a fairly significant loss compared to the unperturbed. And at 25%, there was a fairly minimal loss compared to the unperturbed, at least at the larger data values. At the smaller ones, you notice a much larger decrease than from the initial. And then the 0.5 has a kind of in between. You see after 6%, it kind of starts to drop off a bit more in terms of the accuracy from being 90 plus to less so. So then with that then was the recommender system, which also worked on perturbing the data. How the perturbation worked was with the corresponding chance from above, the p-value of 25, 50, or 75%, for each rating within the data set, it would have that chance of being changed. Then there'd be a 50-50 chance of it either increasing or decreasing by 1. of course, with a ceiling and floor of 5 and 1 respectively. So if it has a value of 5 and it would be incremented by 1, you do not change it. And same for if it's meant to be decremented and it's at 1. So that's another thing that could slightly skew the results, because if you end up having a lot of high ratings, it's a possibility for them to not be affected. So then they also then, with the recommender system, they scored their loss for the varying p-values. And they found that for the loss, the changed p-values, the perturbation, did not have a super large effect, because the variance of perturbation was outweighs the loss increased from increasing the perturbation values. So then our conclusion was that there's not a significant difference between having 6, 7, or 8 pieces of information for an individual in the Netflix data set, and that when you go beneath that, of course, you sort of a much larger gap in accuracy. And then we also found that the perturbation chance at 25% had a minimal impact on the score. Again, specifically at the higher number of values, but at 0.5, so 50% and higher, that's when you start to see a much larger drop. Our further goals are a couple of things. One of them is to measure the effect of perturbating the timestamp, as the perturbation that we have shown there is just the rating. And then as well as also seeing what the results have when you perturbate jointly their rating and the timestamp. The timestamp has a much greater variance of what it could possibly be, as it could span years versus the rating being on a scale of 1 to 5, and then see how that all affects the accuracy of the denummerization process and the recommender system. And then we would like to give special thanks to an acknowledgement to the Department of Defense and the Hume Scholar Program. And then once again mention our reference, Narayan's paper, Robust Denummerization. And of course, if anyone has any questions, you're free to reach out to me.